Hi, I'd like to introduce how to install the Excel XPS macro. So this is the zip file provided by somewhere. You can unzip. So inside we have database here, instruction. You can follow this instruction file to install our macro and sample data here to test our code working or not. This is the code itself, so I would like to copy paste this code into your macro. I would like to start Excel option, customize ribbon to activate the developer tab. So you can see the developer tab here. And we record the macro, personal macro book. Stop recording, and you can see here. Now we click the Visual Basic under the VBA project modules folder. You have seen the module 1. To double click to open. You delete all inside, and you will select all the code we provided and copy and paste. So when you scroll it up, you can see option explicit at the top, and you can see the database location for Macintosh and the Windows. This is the default position is D drive. I would like to change to C drive because this computer has no D drive. So follow this path. So this folder can be copied into C drive. Then you can get the database position as specified here, this path. And we open the Excel again. We assign the shortcut key here, Ctrl Q. Activate the solver for fitting. We also activate the solver library in the VBA, so we can control solver now from the VBA. Now you just quit the Excel and try to open the sample file. Open with Excel and Ctrl Q to run the code, so you can get, if you have charging factor, to calibrate the energy, because these two peaks is a goal for F and use as a reference. So I just shift the peak to the reference position. And if you go to the fitting sheet, we can also Ctrl Q to fit the peak. As you can see, you can control the background and the number of the peak, fitting range here, binding energy for each peak, full width have maximum order each peak, amplitude here. If you change this G to L, we can change the peak shape to the Lorentzian. If GL, we can have a Gaussian Lorentzian convolution. If Ctrl Q is update the fitting result. Yeah, okay. So GL peak fitting provide the mixing ratio of the Gaussian and Lorentzian here. This is the 92%, this is the 65% Gaussian involved in the peak fitting. And this is also important for the spin orbit splitting doublet, 4:3 amplitude ratio for each peak. In case of the fluid surfaction fix, this is the ratio directly effect to the amplitude. So the two peaks binding energy difference also can be specified. In this case, 3.6 eV different constraint we can available, and the area of the peak and normalized area of the peak. This is normalized further by inelastic mean free path, transmission coefficient, and polarization angle to the emission angle. So this is what we can do in the Excel. Very simple. Thank you for listening.